Okay, I think we live. Hello everyone, welcome to the OneClass channel. My name is Millen and I am a software engineering student at Carleton University in Ottawa, Canada. Today, I will be going over some commonly asked physics questions at both the high school and college or university levels. And if you're interested in getting some help with your homework or if you're interested in tutoring, please check out the links in the description below. Cool. So let's get this show on the road and let's experience some physics. So I'm going to switch over my screen real fast and we can get this party started. Okay, so let's get it moving. Cool. So this is the first question that we got on the menu today, and this question is asking us, since velocity is equal to the wavelength times the frequency, that is a universal wave equation, by the way, does the speed of the wave depend on its wavelength? And the short answer is no, but we can take this a little bit deeper here. Okay, so imagine for the universal wave equation, it's V equals lambda f, lambda being wavelength, f being the frequency. So imagine that we have a wave like this. If we wanted to change the wavelength, like shorten wavelength, it would look something more like this. So this would be our lambda previously, and this will be our lambda now. So also keep in mind what happens when we shorten the frequency, when we shorten the wavelength. We're also going to increase the frequency. Well, that's kind of what needs to happen, because you see how the wavelength is shorter, means there's less time between each like peak of the wave, and the time between the peak and the time between peaks, that is the period, and 1 divided by the period is the frequency, 1 over t. So shortening wavelength also increases frequency, and they're like highly connected that way, provided that they are occurring in the same medium. Shorten wavelength in the same medium. Okay, so a shorter wavelength corresponds to a shorter period, and a shorter period, which is t. Why does period is represented with t, even though there's no letter t inside the word period, and that's just kind of the way that it is. But when we increase the period, when we decrease the period, we increase the frequency. Okay, so wavelength and frequency are directly connected to each other typically, but v, the velocity, speed of the wave, v, this depends on the medium that the wave is traveling through. Depends only on the medium that the wave travels through. Okay, so yeah, it's not dependent on the wavelength. A wavelength depends on the frequency, but the speed depends on the medium. Some examples would be like speed of light in vacuum. A light in vacuum is going to be 3.00 times 10 to the 8 meters per second. that's one example of like a speed value that you might have for v. Another example could be something like speed of sound is going to be approximately like 330 so meters per second. So this is just some examples of some different speeds of waves that you might do. Like the speed of sound, of course, is like even a different type of wave. So it depends on the medium as well as the type. But the type of the wave is also kind of associated with the medium. Yeah. So I guess it's fair to say that it depends only on the medium, which also includes the type of the wave. So yeah, the above solution is good. Above solution is good. Cool. Fun stuff.